Welcome to Escape Velocity Space News. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. We are back after a brief break, and while it has only been a couple of weeks, it feels like space science in the United States is in an entirely different place. On May 2nd, the President released his target bottom line numbers for NASA, the National Science Foundation, and other federal agencies. This budget includes a 44% cut over fiscal year 25 to the NASA budget and a 56% cut to the National Science Foundation. If Congress takes these recommendations, entire programs will need to be eliminated, including dozens of NASA missions and numerous ground-based facilities. We are at a weird moment in time. Historically, presidents have said what they want to happen. Congress has done what they wanted. And researchers have gone on a never-ending roller coaster of fearing for our careers, only to see Congress rescue some of us, or all of us, to sometimes seeing the president still manage to kill off our programs, to everything in between. What makes this budget process unique is we have no NASA administrator to advocate for their programs to Congress. And we are seeing programs all across the government getting ended even though they are congressionally approved and funded. A kind of cancellation that appears to steal the power of the purse from Congress while concentrating power in the executive branch. As part of agency contractions, NASA employees received offers to participate in a deferred resignation program, voluntary early retirement, or a voluntary separation incentive program. The 1-2 punch of announcing a budget with desired massive mission cancellations and the receipt of a "wouldn't you like to leave NASA on your own terms" email has many employees realizing their days are likely numbered. At other agencies, these kinds of letters were followed by massive rounds of layoffs, and I am seeing friends who have spent their entire careers on NASA projects, leaving the agency they have dedicated their lives to. At the time that I'm recording this, on June 12th, a large portion of the astronomical community is gathered in Anchorage for the American Astronomical Society's summer meeting. NASA isn't there. However, rather than celebrating recent discoveries, we are mourning future discoveries that may never be made. If this budget goes forward and cuts are made without congressional intervention, I have to admit, this is an extinction-level event. I would love to see the Band-Aid just ripped off of this wound to our research community. Fear is infecting all our decisions as we try and plan for the future. We need Congress to pass a budget so we know how and if things will move forward. We're not going to present you with a list of these are the specific cuts NASA has indicated they will make to conform to the president's budget in this episode. Those cuts aren't real until Congress votes. If you'd like to read through what could happen, check out the detailed coverage from the Planetary Society. And then call your congresspeople and tell them what you would like to see them do and fund. What we're going to try and present is a rundown of our favorite space science stories of the past several weeks. There will be no closer look. There will be story after story of how researchers have been transforming dollars, euros, and yen into new understanding of our universe. From stars stirring the solar system to black holes firing up the early universe, and more. All of this is coming to you right here, right now, on CosmoQuest's Escape Velocity Space News. We are supported by you through Patreon. I've said it before, and I'm sure I'll say it again. Our understanding of our solar system advances at the pace of technology. As our processing power grows, we are able to do more and more complex calculations. And the spherical cows we had to assume to make the math easier are now getting replaced with real physics. In general, we don't actually worry about cows unless atmospheric science, like the study of tornadoes and the air dynamics of cows, are being contemplated, which was an actual study that's in the graphic over there. Anyways, planetary scientists are fortunate, as they often start with spherical planets on nearly circular orbits. Working from the solar system we see today, researchers can run our solar system backwards and forwards, modeling both how our solar system evolved to its present structure and where planets might move in the future. And thanks to new computer models by Nathan Cabe and Sean Raymond, we get to see just how not circular those orbits can get when stars pass a little too close to our solar system. Running models that stepped forward, running through the next 5 billion years of our solar system, they look to see what short-term and long-term effects the gravity of a passing star might have on our worlds. And the effect wasn't at all what I expected. I'm just going to read an excerpt from the paper's abstract to you. Quote, "Our planets and Pluto are significantly less stable than previously thought. Field stars transform Pluto from a completely stable object over 5 billion years to one with a approximately 5% instability probability. Furthermore, field stars increase the odds of Mercury's instability by 50% to 80%. We also find a 0.3% chance that Mars will be lost through collision or ejection, and a 0.2% probability that Earth will be involved in a planetary collision or ejected." End quote. My gut instinct had told me Pluto and other outer dwarf worlds were the most likely to get yeeted out of the solar system. It turns out small tweaks to an inner world like Mercury are massively magnified by the influence of the Sun and other worlds. It all comes down to potential. If you blow on a marble at rest on a barely sloped surface, very little will happen. If you do the same thing to a marble on a steep surface, you could send it on a wild journey. In our solar system, a passing star's gravity is that breath of force that can wreak havoc on worlds. Worlds like Mercury that are on steep gravitational slopes. At least sometimes. Of the 1,000 simulations this team ran with close passages by a star, only 5 of the simulations yeeted one or more planets into someplace that isn't here. Right now, there are no stars known to be on collision courses with our solar system. The probability of a close passage over the next 5 billion years is low. So in all likelihood, none of these terrible possibilities will become a terrible reality for our solar system. But our solar system is just one of billions. And somewhere out there, this will happen to someone. So if you're looking for a good topic for your next science fiction story, here you go. Passing stars, yeeting planets. This work appears in the journal Icarus and was funded by the NASA Solar System Workings Program and Programme National de Planologia in France, and utilized services funded by the National Science Foundation. The idea that bad things happen to good solar systems is a recurring theme in science fiction, with everything from natural disasters to biological disasters to disasters of life's own making, wiping out worlds in book after book. While often these really bad days for alien worlds are just a way of moving the plot forward, they also speak to one of the weirder aspects of the reality we deal with. As far as we know, we are alone in this universe. As of this recording on June 12th, There is no clear evidence of alien civilizations. Yes, pilots, radar operators, and other skilled observers have seen things they couldn't explain. But at this time, definitive proof of galaxy-spanning cultures is just not out there, no matter how much we want to believe. In the summer of 1950, physicist Enrico Fermi brought up this lack of aliens with colleagues Edward Teller, Emil Konpensky, and Herbert York. While the exact phrasing has been lost to time, the story goes that he simply asked, "Where is everybody?" and went on to later do back-of-the-envelope calculations that imply that in an old galaxy where solar systems like ours, but significantly older, should exist, we should have been visited many times throughout history by other civilizations. The lack of clear documentation of such visitations in a galaxy full of potential has been dubbed the Fermi Paradox. By the way, Fermi and his colleagues were working at Los Alamos National Labs when this happened, most likely working on projects funded through the Atomic Energy Commission. Fermi's question is one science can ask: where is everybody? But at this time, it can't answer those questions. We don't have enough understanding about the formation and evolution of life to know how common it is for life to find a way both to exist and to make itself extinct. We don't know how common intelligence might be, or so many other things. But as we go through this summer and celebrate 75 years of not knowing, where is everybody? We're going to pay special attention to science that offers answers as to how these civilizations might have been killed off or prevented from even happening. It's dark. It's depressing. It's a topic that seems on point for 2025. How is the universe trying to kill us? Let us count the ways. So far in this episode, we have planet-eating stars on offer, and up next, I'd like to look at things that go flare in the night, or day, or both. I try to give stories titles that prepare your brain for just what I'm going to talk about. This object? I've got nothing. Astronomers using the Chandra X-ray Observatory have discovered a long-period radio transient that also blasts out X-rays. Long-period radio transients are mysterious objects that blast radio signals for a few minutes every few tens of minutes. This kind of behavior shouldn't be associated with a star's rotation or any of the physics we're used to seeing with pulsars, and honestly, we're not sure what they are other than something small like a white dwarf or neutron star. And a lot of people are putting a lot of effort into observing and trying to understand this new class of object. One of these objects, ASKAP J1832-0911, bursts into life about 2 minutes out of every 44 minutes. Discovered by the Australian Square Kilometre Array Pathfinder radio array, it was found to be less than 150,000 kilometers across and located about 15,000 light years away. While 150,000 kilometers may seem large, it's tiny for a star. The combination of small size and high energy hints at this being a white dwarf or neutron star. Because this system is so weird, it earned extra attention. And what astronomers found raised more questions than answers. In observations over the course of 6 months, they saw a factor of 10 decrease in X-ray emission. A search of archival data found no evidence of long-period pulses prior to November 2023. It's possible this team discovered an object going through a brief period of pulsation. And I don't mean it's pulsating, I mean light is coming at us in random pulses. In a really well-written paper led by Zai-Teng Want that appears in the journal Nature, This team of nearly 50 researchers systematically examines all the possible explanations that would generally come to mind. This is not a rotation-powered pulsar. The radioluminosity is just too bright to fit. It's not an isolated white dwarf. They aren't bright in X-rays. It sort of resembles a white dwarf binary system that has a white dwarf and red dwarf. However, the radio emission could only be explained if this is the most magnetized white dwarf known in the galaxy. They go over idea after idea, and nothing quite works. And that's awesome. This is something new, and a combination of creativity and observations are going to be required to figure out what is going on. This is the kind of mystery astronomers live for, and I look forward to watching them figure out what physics created a solar system capable of blasting out potentially world-destroying X-rays alongside bright radio blasts. This is an object to watch. This work was funded in the United States by NASA, the Michigan Space Grant Consortium, and the Brinson and Moore Foundations. After a break, we'll be back with more news of astronomical objects behaving badly. Stay tuned. Most large galaxies have massive black holes in their core, and woe to the star, dust cloud, or other object that gets too close to their gravity wells. These giant monsters are capable of shredding stars and transforming any material into a luminous accretion disk rich in charged particles that can drive magnetic fields that stream high-energy particles in high-speed jets. In our modern day, most supermassive black holes lay dormant. They have already consumed all their easy meals. When the universe was young, however, food was plentiful and active galactic nuclei were common. Astronomers sometimes refer to the era of active galaxies, when the universe was about 3 billion years old, as cosmic noon. While studying this epoch, the Chandra X-ray Observatory captured X-ray photons associated with high-energy electrons in black hole jets. This is not a gentle process. Cosmic microwave background photons can scatter off of the high-speed electrons jetting out of black hole systems and transform that energy from motion into high-wavelength light, X-ray light, that Chandra can see. In a new paper in the Astrophysical Journal, researchers led by Jaha Matil used new data processing algorithms to identify two systems with extremely long jets pointed almost directly at us. And these jets have particles moving at nearly the speed of light. In one system, the electrons in the jet are moving at 95 to 99% the speed of light. And in the other, they're clocking in at 92 to 98% the speed of light. These jets measure more than 300,000 light years from tip to galactic core. These systems are dynamically changing their environments. Light from the accretion disk, where they originate, can push material away from their own galaxy's core and irradiate that region, ultimately starving the black hole while also disrupting and/or irradiating solar systems trying to form in the blast zone. The jets can also push away material near the galaxy, and their ionizing light can set the remaining material aglow. These are powerful and deadly systems, and it is safe to say that some dreamed of ancient civilizations were prevented from coming into existence by these jet-wielding active black holes. Aren't you glad they mostly existed early in the universe? This research was funded by NASA and utilized both the NASA-funded Chandra X-ray Observatory and the National Science Foundation-funded Very Large Array. Researchers are learning that the jets associated with black holes can do more than we ever expected to destroy their surroundings. New data from the Atacama Large Millimeter Array and Very Large Telescope have captured two galaxies in the process of colliding and merging into one system. Like two balls flying past one another in a bowl made of gravity, these two systems will pass back and forth multiple times before they settle into being one elliptical cloud of stars. During these crossings, the galaxies can pass each other at rates as high as 500 kilometers per second, with shock waves and other effects driving dust, gas, and other material into the galaxy's cores. As so often happens, one of these black holes has woken up and is actively feeding on the infalling material and is messily shooting out jets. What makes this system notable is where one of those jets is pointing. Through random chance, these galaxies are aligned such that one of these jets is striking the heart of the other galaxy. As co-lead researcher Sergei Balyshev explains, here we see for the first time the effect of a quasar's radiation directly on the internal structure of the gas in an otherwise regular galaxy. End quote. With the combined high-resolution efforts of two of the most powerful telescopes on Earth, the researchers have caught evidence of the quasar disrupting all but the densest clouds of gas and dust in the punctured galaxy. Where we would expect to see merging galaxies undergo runaway star formation, this system will go dark. There simply isn't enough material left to form new stars like we'd expect. So yeah, this black hole isn't just killing a couple solar systems, it's killing off an entire galaxy's worth of solar systems. The diversity in galaxy mergers is amazing, and entire careers and catalogs have been dedicated to these systems. A favorite pastime for many merger modelers has been trying to figure out what our own galaxy and the Andromeda galaxy will look like as they merge, and then trying to figure out which of the mergers we see is the one most like what we may someday look like. Except new research led by Til Sawala finds that the Milky Way and Andromeda may not actually be destined to become Milkdromeda after all. Most models of the future merger focus on just these two large galaxies and their motions. But both systems have a small fleet of smaller galaxies in their halos. Of particular note, we have the Large and Small Magellanic Clouds in our halo, and Andromeda has the chunky M32 dwarf galaxy. We also exist in a large group of galaxies that includes the spiral Triangulum galaxy. And it turns out systems of three or more objects like to act out in erratic ways. If you've ever read or watched The Three-Body Problem, you've likely heard that there is no easy mathematical solution, and in many cases, three objects orbiting one another will eventually become two objects and a castaway. In astronomy, 3 is one of the hardest numbers, at least in kinematic problems. If we had a perfect understanding of the exact masses, motions, and density distributions of all the galaxies in our group, it might be possible to brute force out a pretty accurate understanding of how our systems will evolve and merge over time. The thing is, we don't have that information. We have a very good understanding of how the galaxies are moving toward and away from us. Some information on how they're likely moving in the plane of the sky, and rough estimates of mass, and even rougher estimates of the density distributions. So we can't brute force the calculations. Instead, this team of researchers ran model after model, looking at a variety of different possible values to map out all the different things that could happen given our limited knowledge. And it turns out that in under 50% of the cases, Milkdromeda is in our future. But in more than half the cases, we get to fly apart thanks to the influence of our good friends, the Large Magellanic Cloud and Triangulum. These models also confirm that the Large Magellanic Cloud is most likely going to merge into our galaxy, while Triangulum will ultimately merge into the Andromeda Galaxy. It's a galaxy-eat-galaxy universe out there. We just need better data to say with certainty who will be eating whom. Up next, we'll welcome on Eric Mattis with this week's Tales from the Launchpad. Stay tuned. Next up, I'm pleased to welcome on aerospace correspondent Eric Mattis for this week's Tales from the Launchpad. Hey, Eric.
Hi, Pamela. On May 17th, Rocket Lab conducted the See God Sees mission from their New Zealand spaceport. Let's watch the launch.
5, 4, 3, 2, 1. Liftoff.
On board was another satellite for Japanese company IQPS, named QPSR-10. The satellite has a special lightweight antenna and can resolve objects down to 70 centimeters in length. Rocket Lab is contracted to conduct 6 more dedicated launches for IQPS. On May 17th, Iroh launched the RESAT-1B satellite from the Satish Dhawan spaceport. Let's watch the launch.
3, 2, 1, 0. Plus 5 seconds. Liftoff normal. Auto tracking.
The launch on a PSLV XL proceeded nominally until shortly before third stage separation. 370 seconds after liftoff, the telemetry display provided on the webcast showed the planned actual trajectory diverging quickly. This indicated a problem with the rocket motor of the third stage, which is a large solid propellant booster. ISRO ended the webcast with an announcement that the mission could not be accomplished because of a, quote, observation. As of this recording, no cause has been officially determined. RESAT is a radar satellite series intended for dual civilian and military use. On May 27th, SpaceX launched the 9th Starship test flight from their South Texas spaceport. Let's watch the launch. It lifted off in the evening, local time, a precaution mandated by the FAA after the previous 2 flights shotgunned the Caribbean with flaming debris. This was done to allow a huge swath of airspace from Texas to the British Overseas Territory in Puerto Rico to be shut down without inconveniencing too many flights. Compared to all previous flights of Starship, this one had a used first stage, previously flying on IFT-7. Instead of trying to land it again, SpaceX was testing a new re-entry profile and landing sequence over the ocean. The rocket headed up until reaching booster cutoff and staging, which was accomplished in a controlled direction for the first time. SpaceX accomplished this by blocking off certain parts of the interstage. The booster re-entered successfully, but exploded for some reason at the moment of engine relight for landing. The Starship vehicle ignited all 6 of its engines successfully, and burned them to the planned duration, though almost immediately there were signs of fire in the engine compartment and leaks from the fuel tanks. Compared to the previous 2 flights, it did not explode after engine cutoff. However, it did immediately lose control after the engine shut down, and the fuel leaks only got worse. Live camera views from the outside showed the vehicle spinning, surrounded by a huge cloud of propellant, backlit red by the sunlight. This resulted in SpaceX having to cancel one of the 2 planned demonstrations from Starship in space, relighting the engine. They attempted to open the payload bay door and deploy several Starlink mass simulators. Views of the payload bay showed lots of ice and dust particles floating around, not something you want to see for sensitive satellites. However, the door got stuck opening, and no mass simulators were deployed. The Starship vehicle re-entered out of control, with the spin only really stopping when it entered the thicker atmosphere. By then, it was, of course, too late. The camera views of the ship burning up on re-entry were very impressive. Large chunks of the aft fins were sloughing off in a rainbow of different plasma colors. Overall, the Starship program is making negative progress, in my opinion. Starship Flight 9 performs almost exactly like Starship Flight 3 over a year ago, and it is still incapable of carrying a real payload to orbit. On May 28th, China launched the Tianwen-2 spacecraft from the Xichang spaceport. Let's watch the launch. Tianwen-2 is an asteroid sample return mission. It will rendezvous with the near-Earth asteroid Kamo'olaoa, orbit it, and grab samples in a similar manner to NASA's OSIRIS-REx mission to the asteroid Bennu. Kamo'olaoa is thought to be a chunk liberated from the surface of the Moon, given its light spectrum and very close Earth orbit. Tianwen-2 will drop off its samples back on Earth in 2027 and then head to the comet 311p Pan-STARRS. It will arrive there in 2033. China has other Tianwen missions in development, Tianwen-3 to return samples from Mars that will launch in 2028, and Tianwen-4 to explore Jupiter and Uranus, launching in 2030. On May 30th, SpaceX launched the 8th GPS-3 satellite into orbit from Blink 40. Let's watch the launch.
6, 5, 4, 3, 2, 1. Ignition. Engines full power. And liftoff. Go Falcon, go SpaceX, go GPS 37.
Vehicles pitching down ready. Chamber pressure nominal.
The satellite was named in honor of Creola Catherine Johnson, a black woman who was an early NASA mathematician. She was instrumental in calculating the trajectories for many early NASA missions in Project Mercury and Apollo. She also worked on orbital trajectories for later programs and even planned human missions to Mars. Because of her race, she wasn't recognized at the time, but was awarded the Presidential Medal of Freedom, the highest civilian honor in the United States, in 2015. Other GPS-3 satellites have been named after Sally Ride and Neil Armstrong. The launch and payload deployment was successful, with the booster making a landing on the drone ship as well. While we're still talking about SpaceX, there were 9 launches of Starlink satellites since our last episode. On June 2nd, Rocket Lab launched the full Stream Ahead mission from their Mahia spaceport. Let's watch the launch.
5, 4, 3, 2, 1.
Click pad, save code systems.
Beginning Petrova.
On board was another satellite for Black Sky Global, an American geospatial intelligence company. This satellite is the latest in their 3rd generation constellation. They have 2 more launches booked with Rocket Lab. Finally, for this week's rocket segment, the landing of the Hokuto R Mission 2 lander on the Moon on June 5th. Hokuto R is made by Japanese company iSpace and launched on the same Falcon 9 as Firefly's Blue Ghost back in January. Blue Ghost took a leisurely trajectory, performing checkouts for a month in Earth orbit and landing on the Moon a few weeks after that. The lander was equipped with payloads from several Japanese universities and a mini rover made in Luxembourg. Hokuto R M2 took an even longer trajectory than Blue Ghost, arriving in lunar orbit on May 6th. The planned landing time was 1917 UTC on June 5th. iSpace streamed the landing and provided live telemetry, but no camera views. The landing appeared to be going nominally, decelerating at a fixed rate, until the last several hundred meters, at which point the telemetry display suddenly shifted to negative 223 meters. iSpace ended the stream shortly after. In a statement posted on their website a few hours later, they said the laser rangefinder malfunctioned and did not provide accurate height data so the lander did not slow down enough and crashed into the moon. We keep track of orbital launches by launch site, also called spaceport. According to RocketLaunch.live, so far this year, the United States has had 77 launches, China has had 34 launches, New Zealand has had 7 launches, Russia has had 5 launches, French Guiana, India, and Kazakhstan each have had 2 launches, Japan and Norway each have had 1 launch. This makes the total number of launches so far this year 131.
Thanks, Eric. Recent aerospace news just hasn't been the happiest, but there is one moment of watery goodness I'd like to share. On June 10th, Blue Origin shared a video taken at the Johnson Space Center's neutral buoyancy tank that shows astronauts climbing around and on a mock-up of their Mark II lander, which should be transporting astronauts to and from the moon's surface in coming years. Currently, NASA plans not to use the Mark II until Artemis 5, but it is possible its use could be moved forward if Blue Origin leapfrogs SpaceX in their lander development. Blue Origin currently plans to launch their smaller Mark I cargo lander on their next New Glenn launch, which is slated for no earlier than August 15th of this year. We're going to be watching this development closely, and I look forward to bringing you updates as we get them. That's it for now. Good night, everyone. And remember, go out and look up. Oh, and please give this video a like and subscribe, and get notified when new science is ready to be learned. And you can join us over on Patreon, patreon.com/CosmoQuestX, and we'll just email everything to you. Thanks.